let's draw a picture of what's happening here. You have some parabola, let's do a parabola, some parabola that looks like this, and another parabola that opens up that looks like this. You're going to have 2 points where they intersect. And if you took those 2 points where they intersect and draw it down in green, draw your lines down. Does it make sense that I could figure out the area under the black curve? Take out a crayon. Ooh, I don't have a black. Oh, I do have a black crayon. I could find out that this area under the black curve is with the black crayon. And I could figure out the area under the blue curve with the blue crayon. And this is where crayons work wonderfully. There's just enough little see-through so you can still see the black underneath and the blue. And if you wanted just this part left, the area between the two curves, can you see how simple it would be to take the one area and subtract the other area? And that's all that's going to happen. That looks like a very friendly monster. Something about it just has good proportions. Okay, so that's what we're going to do. You just take one integral and subtract the other integral. And because we have properties of integrals, we can undo the subtracting and put it together and just subtract the functions, causing us to do less math, less relaxing time. Okay? And the beautiful thing about the area between curves is that when you subtract two curves, it actually won't matter if some of it's above the x-axis and some of it's below the x-axis. You can think about this and work it through, but it actually doesn't matter that some of it's negative and some of it's positive. The subtracting will make that all work out perfectly. And so even if our original x-axis was moved up here, oh, it's like the bandit guy now. Even if that happened, the area would just be subtracted to and not have to worry about positives and negatives or anything. So it becomes really easy and really straightforward. And as a result, really fun. So we have one parabola. This blue one would be opening up. And one parabola, this red one, that's opening down. Now, it's possible that they never intersect. It's possible that they intersect once, but it's possible also that they intersect twice. And if we're trying to find an area between the two curves, if we're trying to find that, we would need to know what these 2 points are. So first thing we're going to do is to find where they intersect. How do we find where they intersect? Well, we solve the system of equations. They're both y equals, so it's just a matter of saying, well, if they're both equal to y, then the x squared plus 2x plus 2 would have to equal negative x squared plus 2x plus 10. Combine your like terms, and you will get 2x squared equals 8, x squared equals 4, x equals plus or minus 2. So I now know that this point happens at -2, this point happens at 2. If I wanted to, I could add my axes here, but I really don't know where they are, and I really don't need to. Okay? It's not necessary for this question. All that's necessary is that I know that it goes from -2 to 2. And I also, the sketch is important to know which is the function that's on top and which is the function on bottom. Because we are going to do the red function minus the blue function. So as far as setting this up, I'm now going to find my integral between -2 and 2. The red one was -x² plus 2x plus 10, minus the blue one was x² plus 2x plus 2 dx. And the reason it's nice to subtract them within the integral, instead of doing the integrals separate, is a lot of things simplify. So when we go now from -2 to 2, I get -2x². My 2x's cancel out completely. 10 minus 2 is +8. This is all that's left after I simplify, which makes my integral easier to do. Put in my square box, -2 to 2. I get -2x³ over 3 plus 8x. Plug in 2, plug in -2. -16/3 minus 16/3 will be -32/3. 16 plus 16 plus 32. Get a common denominator, add them up, and we get 64/3. And again,
Minus 32 multiplication because it's minus 32.
it's negative, which is fine. It doesn't need to be an absolute value. No absolute values for areas between curves whatsoever. It will find a positive answer in the end. It's just the mathematics, some things when you plug them in become negative numbers. But no, you don't have to make it positive. So I just made this 96/3 and added the -32/3 and get 64. And again, take a moment to marvel at what we just calculated. Rather, wait, okay, I say rather easily, but it's been like 12 years of mathematics that has gone into you to get to the point where you're able to do integrals and understand what's going on. So it's not rather easily. But at where you're at right now, the mathematics is not that hard. And we're calculating something that a year ago, hey, what's the area? Look at these two curves. I wonder what the area is in between. And it's like, haha, yeah, that would be impossible. Right? That's what you would have looked at this a year ago. You'd have been like, haha, yeah, that would be, yeah, sure, nice to find that. Like, why would I want to do that? And that would be impossible. And now, not only, like, we didn't just find a one-off. Like when you have an area of a square, it's like, oh, that's great, but this isn't a square. Now you're screwed, right? Now we can find the area between any two algebraic shapes. We have their formulas, we have their equations, we have their graphs. We can find any area. So it's kind of, I don't know, kind of exciting. Okay? So again, this is is a parabola that opens up. This is a line with a positive green. This is a line with a positive slope. If they intersect in two spots, this is what it would look like. Okay. It is asking me for the area between the two curves, so I'm making a bit of an assumption, thinking that this is going to happen, that it's going to look like this. Right? It could be that the line was below and there would be no area enclosed. It could be that the line was a tangent line, in which case there would be no area enclosed. But it would be kind of dumb of me to ask you to find the area enclosed and then give you equations that didn't work. Probably happened before. Okay? So we're going to try to find this area here. I think you're getting your theme. There we go. Very nice. So if those two black points intersect, that would be where the graphs are equal to each other. How do we solve that? We take the one equation, make it equal to the other equation, and solve. This is quadratic, so I'll move everything over to one side. Oh, how nice. I picked one that factored. Not a coincidence. But it could be you get one, like, math usually works nice only in math classes. When you go out into real life, the numbers don't tend to always work out nicely. You get more decimals, you get more things that need formulas. But now we know that this is happening at -1, this is happening at 4. We could imagine our axes there. Doesn't matter where it is. It does matter, though, that you notice that the green function is the graph on top. The blue function is the graph on the bottom. That's important because when you set up your integral, you'll want to do the green one minus the blue one. What happens if you make a mistake? What if you're like, oh, I did all the math, and then I realized at the end, I did the blue one minus the green one? The answer is going to be negative instead of positive. Then, instead of rewriting everything, I just go back with the red pen, add absolute value bars around everything, and life is good in the end. It's like, I meant to do that just to mix it. Right? Don't redo it. Just add the absolute value. Wouldn't that be nice? Just do a whole question at the end, big absolute value bars, and just say, it must be right. Be the last thing you do in any math step to get 100%. Okay, so we have the integral from -1 to 4. The green one is on top. That is our x plus 1, and we are going to subtract the blue one, which was our x squared minus 2x minus 3, if dx. If we simplify this, we are going to get negative x squared, 2x plus x plus 3x, 1 minus plus 3 plus 4 dx. Square brackets from -1 to 4, negative x cubed over 3 plus 3x squared over 2 plus 4x. Okay, mental math-wise, I would probably first think about those two and say, they already have a common denominator. That's going to give me negative 65 over 3. Then I'm going to do my whole numbers. 48 over 2 is 24, plus 16, that's at 40, plus 4, so that would give me plus 44. And then my other fraction is just that 3/2, which will be a minus 3/2 in the end. At least I put common things together first. Now I would have to get a common denominator of 6. So we would have negative 130 over 6 plus 264 over 6 minus 9 over 6. Right? Push. In case that I made a mental math error, we'll put absolute value bars around it. Is it wrong? Is it 125 ohms? Yes. Oh, see, we needed those absolute value bars. There we go. The important numbers were. And we get our answer. Again, pretty cool that we can find out these areas. All right, now the bell is going to ring shortly. This one I'm going to leave for you to do on your own. This one is going to be interesting. So it's a little bit harder. We'll do that one to start off tomorrow's class, and then we'll get into volumes of revolution. If we look at where we're at, we're pretty close to being done this unit. Again, we have a quiz coming up.